Hello and welcome to this section of the Chemistry Tutor. We've done a lot of groundwork here in the last couple of sections talking about what an oxidation number is and the rules for finding oxidation numbers. But really until you get to this section right here that we're in so that you can actually apply all of these rules, you really can't really get a great appreciation for how to do it. So we just need to dive in and work a lot of problems, and that's exactly what we're going to do. It's very important to be able to know how to do these oxidation numbers right, so that you can actually use it for your chemical reactions and figuring out what's being oxidized and reduced later on. If you don't have a good grounding in this, then follow-on topics are going to be tough, even when they're not hard. So what I've done is I've left all the rules on the board. Everything is still here. I haven't really erased anything. Everything's still here. And what I'm going to do is work on the right-hand side for all the problems so that what we can do is refer back to the rules that we've already used. So you don't need to write anything down as far as rules. I've got them all on the board. And they're in your books. You might want to jot them down at some point, but as far as working these problems, I've already got them on the board. So let's jump in. I think you'll be surprised at how some of this stuff ends up working out. So let's do problem number 1. We have a potassium ClO4. Okay, so this is a compound. We've got potassium atoms in there, we've got chlorine atoms in there, and we've got oxygen atoms in there. And so, if you just look at it, if you look at the periodic table, you're going to say to yourself, okay, well, potassium likes to have charge of +1, chlorine likes to have charge -1, and oxygen likes to have a charge of -2. That's what we would typically say from everything we've learned up until this point. Some of those answers are going to be right, but one of them is not going to be right. So if you just go from your gut instinct, what you think should be, you're going to be wrong a lot of times. You have to use the method that we've outlined here. So the very first thing we do is we go and we look at the priority order. Rule number 1 says for atoms in neutral molecules or whatever, the sum of the oxidation numbers has to be 0. And rule number 1 applies here. In fact, rule number 1 is always going to apply because we're almost always going to have neutral atoms here. So the way that I want to put this down is I want to put an asterisk here, just to kind of remind myself. What I'm going to say is that the sum of the oxidation numbers is going to be equal to 0. And in parentheses, I'm going to put rule 1. This is not something you have to do, but what I'm going to do is write down what I'm doing, and I'm going to put the rule that I'm using so that if you're on a test and the teacher sees that you know what rules you're using, then you can get some partial credit if you don't get the final answer correct. All right, so I like to do that. Plus, it also reminds me of what I'm doing. So I've done rule number 1, okay, and then I go down and look for rule number 2, and I see, does rule number 2 apply? Well, it says in compounds group 1A metals have oxidation number +1. What we have here is this guy, and this guy is in column number 1, so it is a group 1A metal. All right, so I'm going to put an asterisk here, and I'm going to say that for potassium, K, the oxidation number is +1. All right, and I'm going to write down to myself rule number 2. Okay, because rule number 2 applies. All right, now the next thing you have to do is look and say, okay, do I have enough information to find all the other oxidation numbers? Well, I know the oxidation number here, and I know they all sum up to give me 0, but I don't know what chlorine is and I don't know what oxygen is, so I don't have quite enough to do the final answer. So I go down and I say, do I have any group 2A metals, right? I don't have anything like that in there, so I skip over that. Let me go to step number 3, or rule number 3. Do I have any fluorine in here? And I go over here and look and I say, I don't have any fluorine in there, so that's not a big deal. Then I go and look at number 4. Do I have any hydrogen in here? I go over here and I don't see any hydrogen, so that doesn't apply. I go down to number 5. Do I have any oxygen in here? And oxygen would be a -2. I do have oxygen in here, so I put a little asterisk and then I say the oxygen is -2, and that's rule 5. All right, so then I go back and look and see, do I have everything needed to find everything here? I know what potassium is because that was given in the rules here. I know what oxygen is. I don't know what chlorine is. So I think, okay, a lot of students will think, okay, well, I'm going to go and keep looking. So I'm going to go keep looking down here and down here. Eventually, I'm going to get down to the group 7A nonmetals, and I'm going to see that they have oxidation number -1. So I might be tempted to put for chlorine -1 here and say, okay, I've got all the oxidation numbers, but you would be wrong, okay, if you do that. Because believe it or not, even without going to the bottom of this list, I actually have enough information here to find the answer. And the reason is because I know what potassium is, I know what oxygen is, and I know that the sum of all of these oxidation numbers in this compound have got to be equal to 0. That is critical, crucial information. So let me see if we can use this. What is the oxidation number of potassium here? We just said it was +1, so I'm going to say, okay, 1. What is the oxidation number of chlorine? I don't know what it is, so I'm going to add to it, I'm just going to put Cl there because I don't know what that oxidation number is. What is the oxidation number of oxygen? Well, it's -2, but I have 4 atoms here, so I have to say 4 atoms times -2 for each one. And all this stuff has to be equal to 0. What I am doing here is I'm applying rule number 1, which is the very first rule in all of these things. All right? So I found rule number 1, I had to use this rule, I had to use this rule, but when I get down to this point, I can write like a little tiny equation there, and I can figure out what chlorine is, because the sum of these guys have to be equal to 0. So what I do is I say 1 plus Cl, 4 times -2 gives me -8 is equal to 0. And then I have Cl minus 7 is equal to 0 because -8 plus 1 gives me -7. And if I move the 7 to the other side, then chlorine is +7. So what I have found is the oxidation number of chlorine is actually +7. So the way that you write this down for your answer, or you can do it any way you want, you can circle them, I guess, but a lot of the ways that you'll see it is you'll see the compound rewritten, KClO4. And the way I like to do it is I like to draw a line from the potassium, and you just put +1 up here. Put the line from the chlorine up here, and you put +7 up here. And you put the line from the oxygen, and you say -2. So when you have lines drawn like this with plus or minus signs in front of the numbers, everyone's going to know that these are oxidation numbers, and that's what you have. So if you like, you can circle these on your paper, but this really explains and shows that you found every element's oxidation number, and here they are. And notice that the sum of these guys, the sum of these oxidation numbers, is 0. But you have to take into account how many atoms of each you have, because when we say that oxygen has an oxidation number of -2, that means that every oxygen atom in there has an oxidation number of -2. So you have to go -2 times 4. That's going to give me -8. So I'm going to have -8 from this. Here I'm going to have +8 when you add these together, and when you add all that together, you're going to get 0. So let's make sure, and let's see what's the wow factor here. We found that chlorine has an oxidation number of +7. That is nothing like what we would guess from looking at the periodic table. In the periodic table, chlorine sits way on the right-hand side, right by the noble gases. And in previous sections of this class, we've talked about that chlorine likes to have a charge of -1 because it's right next to those noble gases. In fact, we can see that down here in 2-element compounds with metals. Group 7A, which includes chlorine, likes to have a -1. But number 1, this is not a 2-element compound. Okay, this is a 3-element compound, so that doesn't apply anyway. But even if it was a 2-element compound, it didn't matter because we had enough information to find the oxidation number of everything in there before we got down to this rule. And that's what I was trying to tell you. If you just look at the elements and just try to give oxidation numbers based on just looking at the periodic table, if you don't follow the priority pecking order, you're going to get the wrong answer a lot of times, because this is just a bookkeeping method. It doesn't necessarily mean that the charge on chlorine is +7. It just means that we have a set of rules that we use to assign these numbers, and it just so happens that when we do it this way and we track before and after the reaction happens, we can see what changes, and that tells us what's been oxidized and what's been reduced. All right, so let me erase this. We'll do some more problems and give you some practice with that. But what you need to do is go and write down your rules. You're going to need to do this almost every time. So basically, you're going to be calculating the value of the last element's oxidation number by summing them up like this. So get used to dealing with that, because that's how we're going to do most of these problems. All right, let's say we have the compound K2SO4. All right? So we want to find the oxidation number of everything in here. All right, so the very first thing we do is we notice that is a neutral compound, and rule number one is always dealing with if it's neutral or if it's an ion. So if it's always neutral, rule number one means the oxidation numbers, the sum of them, are going to be equal to 0. All right, so the way I do it is I put a little asterisk here and I say the sum of the oxidation numbers is equal to 0, and that's rule 1. I'm just going to remind myself of that fact. So then I go down and look and say, okay, does rule number 2 apply? Do I have any group 1A or 2A metals? And in fact, I do have a potassium here. So what it tells me is K is +1, and that's rule 2. Basically, everything in column 1 and 2 of the periodic table is so reactive and so volatile that it's always going to want to form either a +1 or a +2 ion every time it forms. So that's why it's so high up on the list. It's very guaranteed for that to happen. So since we have a potassium, we know it wants to be +1. All right, so then we go down the list. Do I have any fluorine in this compound? No, I don't. Do I have any hydrogen in this compound? No, I don't. Do I have any oxygen in this compound? Yes, I do. And it's an oxidation number of -2. So what this tells me is oxygen is -2. And then I look and I write down this is rule 5. Okay? And then I ask myself, do I have any rules, or do I have enough information on the board to find sulfur, which is the only thing that I'm remaining, that I have remaining? And the answer is yes, I do have everything I need because I can sum these guys up. So for potassium, it's +1 for the oxidation number, but there's 2 of them. So I say 2 times 1 plus the oxidation number of sulfur, which I don't know, plus the oxidation number of oxygen, but there's 4 of them. So I do it like this because I have 4 atoms of oxygen, each with a -2 oxidation number. So 2 times 1 gives me 2. 4 times -2 gives me -8. And now I just add these guys. 2 plus a -8 gives me -6. And then I move the 6 to the other side, gives me +6. So the oxidation number of sulfur is +6, and that's the final answer. Now, if I wanted to write this down the way you might want to write it on your test, K2SO4, I would write it down. And then I would say, all right, draw a line. Potassium is +1, sulfur +6, and oxygen -2. And these would be the oxidation numbers. I would circle this. That illustrates everything nice and compactly, or I could just circle it on your test. Notice that if we continue going down here, the only thing on this list that talks about sulfur is this one here, where it says the oxidation number would be -2 because it's in that column 6 over there for sulfur. Obviously, the answer we got is not anywhere close to that. We got a positive number for the oxidation number of sulfur. Also notice that this is in reference to 2-element compounds with metals. So this is not a 2-element compound at all anyway. So even if we got to the bottom of the list, that rule wouldn't have applied anyway. So a lot of time, notice there's no rule here talking about copper or talking about aluminum or talking about any of those things. Basically, the oxidation number rules tell you what the most reactive things are going to want to do. The oxygens, the hydrogens, the calciums, the sodiums, and they lock it down. And then we know that because the sum of the oxidation numbers have to be equal to 0, you're always going to be able to find out what that last one is just by doing the math here. So that's kind of how you need to kind of attack these problems. Write down what you know and then use the math to find the last remaining one. All right, so let's look at another one, Al2O3. So the first thing we do, rule number 1, you should know by now, talks about if it's a neutral compound, then the sum of the oxidation numbers is 0. This is a neutral compound. So first thing I'm going to say is the sum of the oxidation numbers is 0, and that's rule 1, okay? And then I go and look and say, okay, do I have any group 1A or 2A metals? I don't have any of those. Do I have any fluorine? I don't have that. Do I have any hydrogens? I don't have that. Do I have any oxygens? I do have oxygens. So I will go over here and I will say for oxygen is -2, and that's rule 5. So then the first thing you do is you say, oh, do I have enough information to find the answer to aluminum, which is the only other thing I have? And the answer is yes. I don't need to keep going down the list because I already have enough information to find all remaining oxidation numbers. And like I said, I'm trying to get you to understand that the very last thing you're almost always going to do is use the math here. So I have 2 aluminums, so I'm going to say 2 aluminums, right? I have to keep track of the number of aluminums I have, plus 3 oxygens, each with a -2 oxidation number, and they have to sum to 0. I'm using both of these rules to write the simple little equation here. So 2Al minus 6 is equal to 0. And then I move, to solve for Al, I move 6 over here. 2Al is equal to 6. And then to get aluminum by itself, I divide by 2. So Al is equal to 3, positive 3. And that is the answer there. So that's the oxidation number of aluminum in this compound. So if I do Al2O3 and I want to represent it, typically how you might do it on the test, for the aluminum, it would be positive 3, and for the oxygen, it would be -2. And that would be the way that you'd probably end up writing that. Now, this little equation thing is probably the most algebra that you'll see in a chemistry class, but it's a great example of how you might actually use algebra for something besides algebra class, right? So you're writing a little equation. You know the sum of the oxidation numbers have to be 0, and you're literally writing it out. 2 times whatever this is plus 3 times -2 has got to be equal to 0. We're moving this over, and then we're dividing by 2. If that kind of math, you know, the math of solving that simple equation seems foreign to you, then go back and get my algebra materials to refresh your memory on how to solve simple equations like that. But that's what we're doing here. All right, for the next problem, it's a little bit different. Very simple, I just want to point it out to you. What if you have the compound P4? So 4 atoms of phosphorus bound together, and I ask you, what is the oxidation number of phosphorus here? Well, it's very simple actually, because this is a neutral compound, right? 4 atoms phosphorus, there's no charge anywhere, so it's neutral. So you know that the sum of the oxidation numbers have to be equal to 0. And because you have 4 identical things bound together, they're all going to have the same oxidation number. The only way that this can have oxidation numbers that all add up to 0 is if the oxidation number of phosphorus is 0. So the way you would write it down is you would say P4, the oxidation number of this is 0. And this is what you're going to see all the time when you have atoms off by themselves, or little molecules that have the same atoms, like hydrogen gas we talked about, H2. You know, the oxidation number of that was 0 as well, because the sum of the oxidation number of all of these phosphorus atoms have to be 0. And so that you add them up, the only way it's going to happen is if the oxidation number of the phosphorus atom is 0. So when you see something off by itself, like an iron atom or an H2 or Cl2, chlorine gas, or something by itself, and it's neutral and it's over there by itself, the oxidation number is basically going to be 0 for that element. All right, the last problem we're going to do in this section is going to be Na2O2. Na2O2. Okay, and so what I'm going to do is go in priority order down the list. So this is a neutral atom. There's no charge on it, or it's not an ion or anything. So the sum of the oxidation numbers is equal to 0. Sum of the oxidation number is equal to 0. All right, so then let's go down the list. Okay, do I have any group 1A metals? And the answer is I do. I have a lot of sodium here. So the sodium is positive 1. All right? And then the question is, you always have to circle back every time you write something down. Do I have enough information to find the answer to all of these things? To find the answer to all of these elements? And I do. I don't have to even look at this anymore. I don't need to do anything else because I've got enough information. So the way you do it is you say 2 times the sodium plus 2 times oxygen, whatever it is equal to 0. Okay? And actually, just to make this clear, instead of 2, 0, it looks like 2 times 2, 20 because of the 0 there. I'm going to put oxygen. 2 times oxygen is equal to 0. So this is going to be 2 plus 2 times whatever oxygen is. And then I move this over here. So I'm going to have 2 times oxygen, -2. I move that over there. And then to get oxygen by itself, I divide by 2. So I get -2 divided by 2, and I'm going to get -1. So the oxidation number of that oxygen in there is -1. All right? So if you wanted to write that down, Na2O2 what we have found is the oxidation number of the sodium is +1, and the oxidation number of the oxygen is -1. And that is the answer. Those are the oxidation numbers. A couple things I want to point out about this while we're here talking about it. We didn't really need to go down the list anymore because once I had, it's only 2 elements here. I mean, there's subscripts, but there's only 2 different elements. So once I know that the sum is equal to 0, and once I lock down any of these in here, then I can use math to calculate the final one. I get an answer that's -1. Notice that if you look at the periodic table, most of the time oxygen wants to actually be -2. But notice that there's 2 things going on here. Notice that number 1, we didn't even need to get down here because we had enough information to solve this problem ahead of time. So before we got down to that. So that's what I'm saying, it's a priority list. You have to try to solve everything as early as you can, and those are going to be the answers. And if it conflicts with something down below, that's okay because it's a priority list. The things at the top of the list matter more than the things that are at the bottom of the list. And you can see that in action here. So it's not -2, it's actually -1. And on top of that, the exception to number 5, if you remember the exception for oxygen, we said there's an exception anyway. When oxygen's bonded to itself, then the oxidation number is -1. And the compound we had, oxygen was bonded to itself. So it makes sense that the oxidation number is actually equal to -1. So we solved it the right way. We shouldn't go down there and see the exception and assign the number and be done. What we should do is write down the sum is going to be 0, write down sodium, and then calculate the answer. But I'm just pointing out that it's consistent. The answer we got is actually consistent with the other rule that was also on the list that was actually a little bit lower priority. Sometimes it'll work out where it agrees, and sometimes, like we've seen in previous problems, the answer that you calculate is totally different than what the list might imply. So it's very important when we do these examples that you're learning how to go in this priority fashion, and almost always you're going to use rule 1 to find the last unknown element by math rather than by just looking it up somewhere. That's almost always the way it's going to be. All right, and that's why we're learning these things, so you can get the hang of that and get the practice with that. So in this section, we've learned to actually use our method to calculate these oxidation numbers. We're going to get some more practice with it in the next section, and then we're going to use it in chemical reactions to figure out what's being oxidized and what's being reduced, which is really important. That's kind of the whole point of learning this in the first place.